So this video is to give a quick overview of how to find acceleration on a velocity time graph. And one thing to remember starting out, and also to find displacement on the same. This is closely connected to physics classroom Kinematics 3 calculator pad, but it would not be exclusive to that. So if you have a velocity versus time graph, what you need to know is the slope of a velocity versus time graph. The slope is equal to acceleration. The slope would be equal to acceleration. So really all you got to do is find the slope of this, since it's a velocity versus time graph. And so the slope is of course equal to slope equals rise over run. So this would be the rise. This is the run. And so in this case, acceleration would be equal to this value here, which would be a positive 15 divided by a positive 5. I'm not going to do that math for you, but I'm just showing you the inputs there. If we go to another question, maybe something like this. It's worth noting, it's again asking for the acceleration, and we are once again dealing with the velocity versus time graph. And again, we remember that slope on a velocity versus time graph, slope does equal acceleration. And so if we go back to acceleration, then is going to equal rise, which is this value, divided by run, which would be this value. So we're going to find here it's going to go from negative 20 to positive 10, so that's going to be a positive 30, and then that's going to be a run, or that's going to be a positive 15. Again, I'm not going to do that calculation. I do want to point out, if we had another situation, say we have a velocity time graph, and say we had something to the effect of where the graph might look, I'll change the color here, it might look like this. Well, in this situation, you'd want to make sure and note that, again, you could find acceleration, and you would have to find, that would be the run, and say this was, say this is at 10 seconds. Acceleration would equal something over 10. What would this rise be? Well, this would be, it's going to be negative because it's going down. But say this is 5 and say this is 20. Well, in this case, the rise would be a negative 15. And so note, you would get a negative value for that acceleration. If we continue moving along, we'll go down to the last one that you will potentially see, and this one has to do with the displacement on a velocity time graph. And let me get a shot of this. So here it's asking for, it's showing once again a velocity versus time graph. So we have velocity, it's critical, velocity versus time. And it's saying determine the displacement of the object for the first 3 seconds. So what we're looking at there is, it's saying right here is 3 seconds. So it's saying, what is the displacement during what's happening right along here? And if you remember from your notes, if you don't have it, you definitely should write it down. We said that the area of a velocity versus time graph equals displacement. So here we got to find the area of this area right here. To do that, we need to think about, well, how do you find the area of a triangle? Because this is a triangular shape, of course. So the area of a triangle, if you don't remember, is equal to 1/2 base times height. So in this case here, I'll change colors just to freshen it up. Our displacement would equal 1/2 of base, which is 0 to 3, so 1/2 of 3 times height, which is this distance here, which would be 10. So in this case, our displacement would equal 30 times 1/2, which would be 15. I'm not going to necessarily work this next one out, but I'll at least show you what we would be looking at here. This one says, we'll look down here at item C, it says determine the displacement of the object for the entire 6 seconds. So here it's saying this entire time, what was the displacement? So now what we actually have to find is the area of this whole space, this entire area. Now if you work through this problem as it says, it actually has you in the second one, it has you find the area for the second 3 seconds, which would be you're finding the displacement for the second 3 seconds. So really, the best way to do this is you find the area of this part, which is just base times height. In that case, area of a rectangle would be base times height. And then you would add it to the area of the triangle, the one you already found. And if you think about it, that should make logical sense. You'd add it to this, because if you think about it, the total distance that he traveled should be the distance that he traveled here while he was accelerating, and then plus the distance he traveled here, or the displacement that he had as he stayed at that constant velocity. Thank you. Hopefully that helps. Best wishes and have a great day.